So here's an old constructed response question that has to do with water leaking out of a bucket. And so the problem states that we've got a bucket, it's full of water, but it's got a leak on the bottom. The bucket's going to be losing water at a rate of 0.5 gallons per minute. After 6 minutes, they tell us how much water is in the bucket. We've got 9 gallons of water in the bucket after it's been leaking for 6 minutes. What part A says is how many gallons of water were initially in the bucket. And so when I read this, I kind of recognize that I need to base this answer off of what they told me in this last sentence here. Right after 6 minutes, the bucket has 9 gallons left in it. So my mindset was, I want to know how much water leaked over the course of that 6-minute stretch. And so if it's leaking at 0.5 gallons per minute, one quick calculation I can do is listed right here, and this calculation will tell me how many gallons of water have leaked over the course of the first 6 minutes. So if I do 0.5 gallons per minute times 6 minutes, that tells me that 3 gallons leaked over the course of the first 6 minutes. So how much did the bucket have in it initially? Well, if it had 9 gallons after leaking for 6 minutes, and we know this is how many gallons actually leaked out over the course of that stretch of time, we'll just have to bump this up by 3 gallons to get how much water the bucket initially contained, 12 gallons. In the second part of this, they ask us to write an equation in point slope form to model the number of gallons, so gallons is going to be represented by y, of water in the bucket after x minutes, so x is time. And so what I did right away is I went to the formula sheet for the Keystone test and I grabbed point slope form off of that formula sheet. Here's point slope form. Now, point slope form is probably not the most familiar form for us to use for the equation of a line, but it's really flexible. It's nice, it's easy to use. The slope of our line has to go here, obviously, so we need m, the slope, to go here. And then the nice thing about point slope form is that x1 comma y1 can be any point that's on your line. And so what I realized here is that it told me the rate that the gallons were leaking from the bucket. We had a rate of 0.5 gallons per minute. And one connection that we've made between slope and rate is that those things are actually equivalent to each other. So not only is this number here, 0.5, going to be my rate, it's also going to be the slope of the equation that I'm trying to build. Now the really, really tricky thing here, and I actually didn't even catch it the first time that I went through this problem, is the fact that we need a negative in front of that 0.5. And if you think about it, the amount of water in the bucket is going to be going down, right? It's leaking water, it's not being filled up. So we're going to have our line go down, and to have the line go downward, it's got to have a negative slope. So that's probably the sneakiest thing about part B here, is the fact that this slope has to be negative. The only reason why I caught my mistake is because I was doing more work with this in a later part to the problem, and my work wasn't really seeming to match up with what I thought it should, and so I came back and I kind of realized that I overlooked this negative back here in part B. But you do have an option here. You know two ordered pairs that have to be on this line. You know that after 6 minutes, so that's an x, that there are 9 gallons left in the bucket. So 6 and 9 go together as an x and a y. And you see that's the one that I actually have listed on this line right here. So I did y minus y1 equals the m times, in another set of parentheses, x minus x1. The alternative would be, since in part A we figured out that we had 12 gallons of water in the bucket initially at time 0, we could also use this ordered pair, and the only difference is, you see I have a 12 going in for y1 and a 0 going in for x1. Either one is fine. I would go with the one that has to do with the ordered pair that they actually told us, because if you made a mistake in part A, it would stink to carry that over into the next few pieces of the problem. So best thing to do would be to use the sentence right here at the end of the problem statement, 6 as an x amount of time, and then 9 gallons of water at that time. In part C, they say, how many minutes does it take for the bucket to lose 7.5 gallons of water? Now, I took two different approaches here, and both approach gets you to the same result. I think this problem is easy enough to use guess and check with, and that's what you see that I carried out over here. So I said, well, I'm going to figure out how many gallons of water the bucket has lost after 10 minutes. So I took my rate, 0.5, multiplied it by 10, and I realized I had 5 gallons leaking over the course of that 10-minute stretch. And I said, well, I'm trying to figure out how long it's going to take to lose 7.5. So I'm going to bump that amount of time up a little bit from 10 to 20. How many gallons does the bucket lose over the course of 20 minutes? Well, 0.5 times 20 gave me 10.5. Now I'm a little bit above that. What I actually realized, though, is that 7.5 was smack dab in between these. So I guess and checked with an amount of time that was right smack dab in between these. After 15 minutes, 15 times 0.5 gives me 7.5 gallons. This work right here, keeping the guess and check work within a table, kind of like I did, gets you this answer. The alternative would be if you would like to use your answer from part B, if you want to use this equation right here, what you're looking for is you're looking for a certain number of minutes. So you're looking for an X, right? So you see what I have written out right here. I haven't found X yet. That's what I have down in the bottom right corner of the page, but I'm looking to find what X is. Now what makes this a little bit trickier is that 7.5 is not the number that we're going to put in for Y. And the reason why that is because Y is going to be the number of gallons left in the bucket, right? Not how much has leaked, but the number of gallons left. So we started with 12 gallons in the bucket. If we have 7.5 that have leaked out, we've actually only got 4.5 left in the bucket. So I put that number in for Y in this equation back here from part B. 4.5 minus 9 gave me negative 4.5. I distributed over here because I want to try to find what X is. So when I did a negative times a negative, that did give me a positive 3. And then if I subtract 3 on both sides, I end up with this equation written out across this line. I realize I want to get my X by itself, so I divide both sides by negative 0.5. And I get the same answer here, X equals 15, as I got with guess and check. So yeah, guess and check, not too bad in this case. Sometimes guess and check can get a little bit ugly if you have an answer that's not nice. Like what if it was going to be 15 minutes and 5 seconds? Well, guess and check would have been pretty tricky to use to figure out this answer. This would have been about the same difficulty either way. So is this a little bit trickier based on the answer that we got? Yeah, but hopefully you realize if this would have ended up being not a whole number of minutes, if it ended up being a decimal or a certain number of minutes and some seconds, this would have been a little bit trickier to do. And then in the last part here, it says, what is the total number of minutes it will take for the bucket to be completely empty? And so when the bucket's empty, Y is equal to 0. So I did do what I did in the second part of my second version of part C here. I realized from this equation in part B, I want to know when Y is 0, when there are 0 gallons left in the bucket. And so I put 0 in for Y in my equation from part B. And I wanted to find X. So it's very similar to what we talked about at the conclusion of part C with the second method of finding the answer to it. I distributed in over here, right? So I got negative 0.5 plus 3 again. So once again, you see distributing negative into a negative gives you a positive. And then 0 minus 9 is just negative 9. I wanted to find what X is, so I subtracted 3 from both sides, divided by negative 0.5 on both sides, ended up with 24. Could you have gotten this with guess and check? Yeah, you need to know how many minutes it's going to take in order for 12 gallons to leak from the bucket, right? So you could have basically done this kind of like we did with this table here, but it's not 7.5 gallons that the bucket's losing. It would be, if it's empty, it's losing all 12 of the gallons that it started with. So that would be an alternate way of getting this, but hopefully you understand what we've talked about in this video.